Okay, for what we have regarding absolute value equations, first of all, we have for the definition of absolute value, that is the distance or the number of integral units away from zero on a real number line. And we have the absolute value of x is denoted as, okay, where we have x in between what appear to be vertical slashes. And for what we have for absolute value, that is never going to be a negative quantity. And just some samples of looking at absolute value. Say we have with the number 3, and the number of integral steps away from 0 is going to be 3 spaces. And so we have, in effect, okay, for the absolute value of 3, okay, that is equal to 3 itself. So you have 3 spaces to the right, so the absolute value of 3 is equal to 3. And for what we have regarding, say, the absolute value of negative 2, and number of units that negative 2 is away from 0 is going to be at 2. So we have, in effect, okay, the absolute value of negative 2, again, is not negative 2, but positive 2. Again, absolute value is never a negative quantity. And if we have, let's say, for negative 4, again, negative 4 is going to be 4 spaces away from 0. And we have here the absolute value of negative 4 is equal to 4, and since we have no motion away from 0 on 0, in this particular case there's no horizontal movement left or right, and so we have for the absolute value of 0, okay, that is equal to 0 itself. Now as we cross over to absolute value equations, okay, again, absolute value is never negative, and for non-negative value k, if the absolute value of x is equal to k, then x is equal to plus or minus k. And let's say that if you're looking at solving for x, and we have, let's say just for example, if we've got the absolute value of x is equal to 7, well, in this one, once we take out the absolute value bars, we have x is equal to positive or negative 7. And so we have here, so we have both negative and positive 7 will be 7 spaces away from 0 on the number line. And let's say that if we have the absolute value of x minus 4 is equal to 17. Now we have here, okay, we have for the absolute value of x minus 4, if it is 17, then we have 2 numbers with absolute value of 17. One's going to be positive and the other one's going to be negative 17. And looking at the values of x, so if I have x minus 4 is equal to negative 17, and also we have x minus 4 equal to 17. And if we look at adding 4 to both quantities, we have x is equal to negative 13 on the one end, and for x minus 4 equals 17, we have x is equal to 21. And so we have with our two values, we have at negative 13 and 21. All right, now we have in the third case, all right, so we have the absolute value of 2x minus 3 is equal to negative 22. And if you notice, okay, you had the absolute value of 2x minus 3 is equal to negative 22. And again, since absolute value cannot be negative, that means in this particular case, all right, there is no solution for x. All right, and let's say that if we have an absolute value equation, and we'll take as a fourth case, if we have, let's say, negative 4 times the absolute value, and we'll say that we have 3 minus 2x, and we have plus 5 is equal to negative 19. Okay, now in the case of absolute value equations, now the object is going to be to isolate the absolute value term, which we had to be that 3 minus 2x, and we're not going to treat the absolute value bars as parentheses, so we're not going to distribute negative 4 over 3 minus 2x in this case. But what we can do in order to isolate the absolute value of 3 minus 2x, okay, we can have, first of all, the subtraction of 5 on both ends. And so we have, in effect, by subtracting 5, okay, so we have -4, and we have times the absolute value, 3 minus 2x, and we have is equal to -24. Okay, now we have here, now while the absolute value of an expression cannot go to a negative, if you notice we have on the outside, we have -4, and we can undo the multiplication by -4 by dividing on both sides by -4. And so for what we have here, okay, we have the absolute value of 3 minus 2x is equal to 6. And there are two numbers that will have an absolute value of 6. So once I take out the absolute value notation, so I have 3 minus 2x is equal to plus or minus 6. And for what we have here, we have 3 minus 2x is equal to -6 on one end, and we have 3 minus 2x is equal to 6 on the other. And if we look at isolating the x terms, so we have take away 3 in both equations on both sides, and here we're going to have -2x is equal to, we have -6 minus 3, so we have -9, and here we have for x, we have -9 divided by -2, so x is going to be at 9/2 at the one end, and taking away 3 in the other equation, so we have -2x is equal to 3, and for x, if we divide, okay, by once again -2, and we're going to have, in effect, x is equal to -3/2. So for this absolute value equation, we have these two non-integer results.